The modulus function is defined as y equals x when x is greater than or equal to 0 and minus x when x is less than 0. What does that mean in terms of a diagram? So, if we draw some axes, the first part then, so y equals x, the line y equals x looks like this here. But we're only interested in the region x is greater than or equal to 0. So from the origin onwards, we've got the line y equals x. So what I could do, in fact, is just to get rid of this section of the graph here. I can't rub it out. I'm going to shorten the line then. Now the second part of this modulus function, y equals minus x when x is less than 0. So we have a line like so. That's the line y equals minus x. Now once again, we're only interested in this y equals minus x when x is less than or equal to 0. So this part of the line does not interest us. So there is the diagram that we want. Now what I could do finally is just remove this part, and this is the graph of y equals the modulus of x. So what we're going to do here is consider an easier way of drawing the graph of y equals the modulus of x. First thing I'm going to do is to draw the graph of y equals x. So I want a line like so. And then what we want to do is to reflect this part of the line, that part below the x-axis, in the x-axis. So what we end up with is this here. And then what I'd like to do is to, well, what we could maybe do is we can maybe make this part of the line dotted. So that's part of the graph of y equals x, but we don't need that now. It is useful to show that in the diagram, but it's not entirely necessary. So here we have a first example, some function y equals f of x. What we want to do is to draw the graph of the modulus of f of x. So those parts of the graph which are below the x-axis are reflected in the x-axis. Now that means we have to deal with this region here and this region here. So if I reflect this part in the x-axis, what I get is this shape. And what I'm going to do then is just make this dotted. Or we could rub it out entirely. And we have to deal with this part here, so that too has to be reflected. It will appear up here. So we're going to have something that looks a bit like that. And I'm going to make this part that was originally below the x-axis dotted again. So what we have now is the graph of y equals the modulus of f of x. So we cannot have any part of the graph below the x-axis. So let's consider something like y equals 2x squared plus 5x minus 3. We want to sketch this graph and then sketch the modulus. So the first thing we'll have to do is to factorise and then find the roots, so x equals 1/2 and x equals minus 3. Now it's just a rough sketch that I want. So 1/2 is here, minus 3 is somewhere over here. Now it's a happy face graph because we've got a positive x squared. So there's something like this. We know that the y-intercept is minus 3. It's useful to know that. So that's the graph of y equals f of x. And if we want to sketch the graph of the modulus function, what we have to do is to reflect the negative part of the graph, that part below the x-axis, in the x-axis. So it's going to appear somewhere up here. And the y-intercept at minus 3 will now be a y-intercept at 3. And just to finish it off, what I'm going to do is to remove entirely this part here. So what we now have then is y equals the modulus of f of x.